Can you hear me? Great. Great. So I hear them starting in the next room, so we might as well go ahead and get started. Figured it's the last session of the event, so I'm not too surprised we got a late room, but probably some folks heading out and things. And we're also, how many of you folks know what Trove is and have? Yeah.
I know what it is.
Well, there you go. Perfect. I guess I'm supposed to read the sponsor. You know, we've got Mac CDN sponsoring the room, a next generation content delivery network based in Los Angeles. The whole team is obsessed with speed. Hopefully they mean, you know, network performance, automation, real-time reports, and implementation. So yeah, that's probably network performance. If you want to put some bandwidth through their CDN, head over to maccdn.com for a free trial. So there you go, or speed, I don't know. Just in terms of who I am, I'm Ken Rugg. I'm the founder and CEO of Tesora. And you know, probably more interesting than who I am is who is Tesora, and we're the biggest contributor to Trove at this point. We work, you know, alongside a lot of other people in the OpenStack community contributing to the code. It's a pretty good, diverse community. It's a fairly new project. It became an integrated part of OpenStack. So I ask who's familiar with Trove. How many people are using OpenStack, familiar with OpenStack? A bit better, not a huge, not everybody, not universal, but there you go. But yeah, OpenStack is, I didn't talk a lot about the growth of OpenStack, but hopefully some of you are familiar with that. It's, you know, extremely fast-growing project. And, you know, I saw some information from 451 Research recently where there are more planned implementations and pilots underway with OpenStack as a cloud platform now than VMware, which is pretty amazing. Right? I mean, you know, good success for open source, right? I mean, you know, so I think that's a really big change, and that was a huge flip just from, you know, year over year. So that was a really interesting number. So Trove is, you know, kind of new to the party for OpenStack, you know, and you know, sort of as, you know, I think it's going through the natural progression. I always kind of compare it back to, you know, the progression that Amazon went through. You know, first you start out with S3, and then you have EC2, and then eventually you're going to have RDS, and then Redshift, and you know, DynamoDB and everything else, right? But you know, I think that there's a natural progression as people move different, you know, and start expanding the workloads they put on a cloud. Database is one of the workloads that come up, and I think even, you know, it's because OpenStack is a great platform for private cloud. I think private cloud actually in some ways is has more need for database workloads than public cloud, because public cloud sometimes could be a little challenged on database workloads, either because, you know, privacy concerns or just variability in performance. And sometimes in your private cloud you can have more control over managing the performance profile. So we also, I mean, we've got some history in the database space. We also have an open source transparent sharding product. I'm not going to talk about that at all, but other than to just say, you know, if you're interested, you can find that from us as well. So, you know, again, I think one of the things in kind of looking at, you know, why Trove and why is the world moving into a world of database as a service and managing databases in a different way. When you look at kind of the transformation of IT in general, you know, as you move into the cloud, a lot of those things have special characteristics within the world of databases, right? Because databases historically have always been, you know, your biggest, baddest machine in your data center was your database server. You know, probably running some monster version of Oracle that cost you $1 bazillion. And then, you know, now, you know, a lot of the transition has kind of happened organically as people said, no, we're not going to do it that way. We're going to, you know, find new databases, find different databases, not just Oracle, not just SQL even. And they go out and find different alternatives, which makes the job of the person who's responsible for ensuring that all those databases run properly a whole lot harder, right? Because they all have different characteristics. They all have to deal with, you know, different profiles. You know, how do you tune the schema in MongoDB is going to, you know, have almost nothing to do with how you do it in, you know, historically Oracle or MySQL or anything else, right? It's the world has changed. And I think that, there's also, when you look at the demands of the people that are using these databases, their expectations are being set by Amazon. And, because so they expect to go to a web page, push a button, and have a database server up and running that's backed up, replicated, just works, and they don't have to think about it too hard. So to that, that's kind of Trove is trying to address a lot of those concerns and trying to create a new platform for how you deal with this environment and manage the environment. And what is Trove? It's database as a service or OpenStack. It's kind of like RDS. It's, it lets you, gives you both APIs for both development and operations. I kind of think of it, a little bit like, a soda machine. You push the button, you get the database server you want. It's more than that because it's not just, provisioning, but it's also lifecycle management of the database. So it sort of goes beyond that as well. But but it is, again, I think core to what it is, it's the multi-database. And, again, I think this is, I think about it as, because a lot of people are familiar with AWS and RDS and the facilities are there. Again, I think one of the things that's also different about Trove is it's trying to address a different audience. So within Amazon, the team that runs DynamoDB and the team that runs RDS and the team that runs Redshift, they've got different guys. They've got, because Amazon works at such extreme scale, they can afford that. They can have they can have different technologies for managing lots of different database technologies. Whenever you start moving into a private cloud or even a smaller cloud service provider, it's hard to have the scale to be able to stand up, every different service you add is a tax, right? And it's going to be more manpower and more work and more implementation and everything else. So Trove, one of Trove's goals is to have one common infrastructure where you have some level of consistent, let's see, for operators, so that then when they're interacting and managing this environment, they can do it in some sort of consistent way. At the same time, it is also trying not to be kind of least common denominator. So it does attempt to expose ways of managing the cloud in a way that is that lets you take advantage of the best features of NoSQL or SQL or Mongo versus Cassandra and not try to just make them all homogenized. It doesn't. One of the things that similar to talk about Redshift or RDS. Those are all. Those systems still give you a standard API. You're still dealing with the database server once it's up and running. Same with Trove, right? If you provision an instance of MongoDB, it's not putting a genericized NoSQL wrapper around it. It's not putting a generic SQL wrapper around it. It's giving you an endpoint, giving you a database endpoint that you can then interact with just as you would as if you spun it up yourself. It's just that behind the scenes, if it needs to get backed up, if you want a replica, that's all administered through the Trove APIs or the Trove dashboard. Mission for the Trove project is to provide scalable, reliable, relational, non-racial for extensible open source framework. Pretty straightforward. I think it's probably consistent with all the things I've said already. This goes to the, again, I think when people look at Trove, what does Trove actually do? And it's still pretty limited, I would say. But it does a fair number of things in terms of giving you an implementation of how to manage these things. And not all, one of the things I'll say about Trove, and I'll get to this in a minute in terms of how it relates to the different database servers it's managing. This is kind of the superset of things it does for the various databases under management right now. They're not all at the same level, right? So Trove, one of the other ways that Trove makes it possible to bring databases online quickly is to say, well, if you want to just have provisioning and database and instance resize, for example, and backups, because that's generally, just being able to easily provision, deprovision, resize the instance, and do backups of the thing, that's usually a good level of support for somebody who just wants to be playing with it and do development on the system. And then when you want to start moving it, closer to production or into QA, you start needing replication, you need more services layered on top of that. So Trove doesn't kind of set down a requirement that you have to start out by having all things implemented. it lets you kind of pick and choose the capabilities that you need there. Again, I think that's, significant. It's an open source project, so again, you can take it and do as you like. But when you look at the things that it does do in some of these cases, it does give you ability to do tuning. It gives you the management interfaces, and it does try to apply some sensible defaults for tuning and for security as well. So for example, for default, you don't get the ability to your users once you spin up a database instance, similar to Amazon RDS. By default, you don't have the ability to SSH in. Right, so generally you don't want people, going into their database server if that's a managed server. So by default you do that. You can change that. You can change those defaults, but it just, it's trying to make it, make the default be kind of sensible and managed. Where it's used today, I mean, I think HP and Rackspace both use it in the public cloud, and eBay who's also a big contributor to the project. They're using it in their private cloud, and they actually use it to serve up production workloads for some of their web-facing services. They use it on 5 different databases to date. So they're Couchbase, as opposed to CouchDB. Couchbase, Cassandra, MySQL, Mongo, and Redis are all being managed by Trove in the eBay scenario. One of the things we find is that, kind of a lot of people ask me how are people using Trove typically? What's the use cases? Development and test is, usually where people adopt new technologies for any sort. And, it's the same with Trove, and I think the same with OpenStack at large. And I think, one of the things I sometimes, for me, it's a little bit of a pet peeve because some people say, oh, well, it's just development and test, so nobody's doing real work on it. To me, developers do real work. QA engineers do real work, and making them more productive actually matters, and you actually want them to be productive. And if they can, not have to spend a lot of time worrying about how they configure and manage their databases, and you can, make this all simple to spin and go, that's worthwhile. In web application hosting, again, the typical, eBay being a good example of that, and also on-demand analytics, kind of almost similar to Hadoop-like use cases, but with more traditional database technology. So if you want to just spin up a database server or a bunch of database or a cluster and then tear it down when you're done doing some analysis, that's another good use case for database as a service. So the Trove architecture, so those of you who are familiar with OpenStack and some of the core components of OpenStack, most of OpenStack services, and you look at the core services, are not 100%, but mostly they're self-contained, right? So if you look at, Nova, Nova will rely on Neutron or call out to Neutron to give you network capabilities. Maybe Swift might use the Keystone for authentication and access control and things like that, but otherwise, they largely are self-contained. There's not a whole lot of interaction between the other services. They don't need a lot of the other services to do their jobs. Trove is a little different than that because Trove really does very heavily rely on the other services. So if it wants to launch a virtual machine to run a database server, it calls out to Nova, right? It doesn't have its own machine provisioning mechanism. It uses what's built into OpenStack and really layers it. And I think this gets into, I think one of the things that's interesting is with Trove as part of OpenStack project, is people like, where does database as a service fit into the stack? Is it infrastructure or is it platform? And that's one of these, it kind of fits somewhere in the middle because it doesn't, I think generally when people think about a database capability within platform as a service, usually they take a database server and it's bundled within an application stack. So you're not provisioning, standalone database capacity usually when you're thinking about platform as a service. So it doesn't quite fit there. So I think it does fit more naturally. Database as a service is more aligned with infrastructure as a service. But it is layered on top of some of the other core infrastructure services. So it's a little bit different than some of the other facilities that are provided there. And then, I think, again, another key piece of the architecture to understand is where it fits in and how it manages the different databases, right? So there's this clear split in the code base. When you look at, there's all the Trove controller code, and there's some various processes, there's a task manager and some other pieces there. So it's not completely, it's just kind of a simplification of the architecture. But there's a clear distinction between where's the data store agnostic code and where's the data store specific code. And there's an implementation that's specialized for each of the database servers that are being supported for a guest agent that understands. So, for example, when you go to the Trove dashboard and you say, I want to do a backup of Postgres, or the code that it's actually going to run is going to be different than if you say, I want to do a backup of MongoDB, right? Or MySQL, right? And that gets into, one of the things, that kind of goes into that too is it's also, the code gets kind of broken down and set up specifically to handle the different data stores. You can also, within a given data store, have different strategies. So this is an example where backup, for example, for MySQL, you could back up a MySQL database by doing a MySQL dump and just get a textual dump of the whole database, or you can do something like Percona XtraDB backup. And so this is, so that the code is actually set up so that then by configuring the system, you can configure it either to take one of those two, it's called strategies within Trove, backup strategies, to select what strategy you want to use for the backups for this particular use case. Yep, question?
Is the strategy to choose part of the API call or part of the configuration?
It's part of the configuration. Yep, yeah, so and another thing about the configuration, I didn't mention this too much when I was, go back. So one of the things about the tuning and the management that I didn't really talk about too much is that there's actually a notion, I thought it was on this slide, but never mind. I don't need this slide. There's a notion of configuration groups. So configuration groups are kind of having a specific fleet of servers that are set up to serve a particular workload. So for example, you might say, all of the MySQL servers that I'm using to support Drupal have a particular configuration profile, and they're part of a configuration group. And then you might say, well, I've decided now that all those servers I should increase the size of the connection pool for all the servers that are supporting Drupal. So you can then configure them all. You can basically do fleet-wide management in that way. So it's, so for example, and the strategies can be applied as well that way. And now I'll get into some of how you actually use Trove, whether you're developing it and move from there. So first thing is getting started with Trove. So where do you start? If you just want to use it, just want to try it out and kick the tires, you could go to a distribution that includes Trove. HP's Helion dev platform includes it. Also, there's a tech preview. I think it's part of the Red Hat. I think it's included in, is that true?
Not part of the RDO yet.
Okay.
But it is part of the tech preview of
RHEL.
Of the RHEL.
Yeah. Okay. Or you can get it from us. We have a packaged up version that's tested across all the various other distributions. So we test on Red Hat and Mirantis and HP and all these guys, right? So you can get it from us. As a developer, you can pull it from Git clone from that spot. I'll make all these slides. You don't have to be furiously writing to copy this. Not that any of you are. And RedStack is actually a kind of an apocryphal name because Trove used to be called Red Dwarf, so hence RedStack. And so you can use RedStack is effectively DevStack plus Trove. Or you can sort of pull just specifically start out with DevStack and then pull the specific services and enable servers on top of that. So once you've got it all up and running, so how do you provision an instance? So you do Trove create instance name, flavor ID. Flavor ID if you're familiar with OpenStack, that's a Nova flavor, which is basically a machine instance size, so number of virtual memory, number of CPUs, et cetera. And the volume size, so then how big of a disk you want to store your database on. By default, again, it's configurable, but by default, it's going to expect that to be a Cinder volume. So, so that's, kind of the setup. And then there's some optional parameters for it. Data store type is, there's a data store type and a data store version. So in terms of language of Trove, a data store type is something like MySQL. Data store version is MySQL 5.6. So, kind of what you'd probably expect it to be. It gets a little tricky in the world of MySQL because Percona might be a version, or it might be a type. So that gets whether all the variants of MySQL are versions or types it's not entirely consistent all the time. You can specify availability zones. Once again, it utilizes the Nova capabilities for availability zones, and likewise it uses Neutron for the NIC to specify a specific NIC to use. Things you can do, once you've got it up and running, you can resize the flavor, you resize the volume. So if you need a bigger database server, more memory, what have you, and then within the data store specific extensions. So some databases you can create schemas. Some database servers, database instance types don't have schemas. They don't have a notion. They're just key value stores, for example. So you're not going to create a schema in that case. And some support user authentication, some don't. So create users and things and permissions are things that are there. And then enable root user, whether you want to have a root user to be able to get in there. This gets into, how do you do backups and restores. So the backup, the backup create, you specify it. The way you restore is you basically are creating a new instance using a previously created backup. So the call to restore is not, I've got an instance and I want to restore onto that running instance. The call to restore is launch a new instance beginning from this specific backup. Just kind of the semantics of how that works. In general, by default, it's going to stream that off of Swift, which is object storage equivalent of S3. You can do full or incremental. So getting into some of the stuff that came out, Juno. So if you are familiar with OpenStack, the kind of the release cycle for OpenStack, it's letters of places. We're up to J, was in November, October technically the release came out. So these are some of the things that were new in Juno, and one of the things was asynchronous replication. Now that is not failover. That's not the ability to do for availability, for high availability and failover, because it's just purely asynchronous, and it's not keeping track of transaction IDs. So you can't get kind of point-in-time recovery in that sense. Neutron support was added there. Previously, was just doing Neutron Nova networks. Support for Postgres was added, and some configuration groups, some other incidentals, and again, backups, Cassandra, and Couchbase. Again, all of the guest agents for all the various databases are continuing to evolve over time as we try to get them all cut on par. Both add new ones and get the existing ones up on par, so people can move further down the path. So the replication feature of Juno, that's basically done using create, and you're creating it as a replica of, kind of very similar, just as if you're doing it as just an extra argument where you're doing a replica of, and it's basically just support increased load for handling more read load for read replicas. And you can manually detach it, so if you want to spin up a replica, detach it so that then you can go off and do some testing and not have it continually be updating and kind of get it off of the workload, you can do that. We also added clusters in Juno. So clusters give you the ability to specify the flavor ID and the data store and the version and the volume ID and all that kind of good stuff. The clusters do not have to be homogeneous. So, for example, Mongo has kind of a notion of a head node and then the database servers, and there's kind of a management node. So you can specify different node types and specify different kind of nodes whenever you're actually launching the cluster and spinning it up. And also you can specify, so for example, with Mongo, you're specifying some number of shards with so many replicas. So, if you get 3 shards and 2 replicas of each. So you can specify that all in the command to spin up the clusters there. So plan for Kilo. So things that are coming out in the Kilo release, and that's coming up in the spring at the Vancouver session. Building out more of the clusters. So semi-synchronous MySQL clusters using Galera is one of the things that's being added in that release. The second rev of the asynchronous replication, that should say replication for MySQL as well. That introduces the ability to actually do failover. So global transaction IDs, so you can actually do failovers and things there, because that's clearly one of the big reasons why you'd actually want to use replication beyond just workload management. You can associate flavors with data stores, and what that means is, so for example, Cassandra will not work very well if you have less than about 4 gig of memory on the machine. So you would specify that you can't use Cassandra by flavor with under 4 gig of memory. It won't boot basically if you try that. So it's better for the system to actually know that and enforce that for you. And then just some other various things about testing and things. So where can you get OpenStack Trove? There's the various places to get the source. So it's various projects in OpenStack that you can pull from the Git repositories that we've listed up here. Again, as I said, all the slides will be available for you to pull from, and then the installable packages you can pull. Our version for the pre-configured installable packages. One of the things I didn't really call out. One of the things we do at Tesora is we build pre-configured guest images. So the guest image is effectively your virtual machine image, which includes the database server and the guest agent. So the guest agent is effectively the code, as I mentioned before, that's where the management proxy code is. That's translating that code where it says, okay, so if I want to do a backup of Postgres, what does that mean? And then it can issue the commands to the database server on the same virtual machine host. So one of the things we do is we create those guest images, so they're pre-bundled, so you can just launch them directly as opposed to having to manually do that yourself. And how do you get more information about Trove? Lots of places for that. One of the things we did as Tesora, we did what we called Trove Day last August, and just had some for example, the guys from eBay spoke and talked about their implementation, kind of some of the challenges they faced and things that they did to get Trove up and running. And so that's all on the slides, and the video of that are all up online, where you can pull those and get those to see what those guys are talking about. So that definitely recommend that. So, and if you want to get in touch of me and Tesora information. So I feel like I went fast. so I'll let you all get out of here quickly. But any questions?
Is Trove still in incubation?
No, Trove is a part of the integrated release.
Okay.
So as in Icehouse, Trove became part of the integrated release. That long ago, yeah. So it was last April. Icehouse, I comes before J. Icehouse was released in April of last year. Yeah. Yep.
Postgres support seems to be somewhat lagging behind. Is that lack of demand?
Yeah. So yeah, Postgres support is a bit behind. Well, so a couple reasons why Postgres support is a bit behind. First one is it goes a little bit. It's a little bit historical. And the history of, Trove going back to Red Dwarf was HP and Rackspace said, we need something to compete with Amazon RDS, right? And Amazon RDS at the time when they said that to each other was all about MySQL, right? So they wanted to have a service, and so all the initial work that went into it was get it out on MySQL to be able to basically have a competitive offering, right? The next thing that happened was, kind of a position of saying, well, and eBay was one of the drivers for this, to come in and say, well, we would like it not to be not just SQL. We also want the NoSQL databases supported, and we need an infrastructure where we can manage SQL and NoSQL in the same infrastructure. So that kind of those databases kind of took the lead ahead of Postgres, right? Then just this past year, it was like, so now that we've started expanding out the support for the NoSQL, now it's time to, sort of just start taking inventory and what do people actually want to run. And we've seen a lot of people want Postgres. Postgres has been one of the ones that's been requested a lot from us. We find, people asking, what we found is probably Cassandra is really popular. A lot of people want to run Cassandra in Trove. MongoDB, and MySQL and Postgres are similar, but it's kind of hard to read it because, it's always a classic, do the people who want MySQL just go to the community and just get what they need because it's probably the ones farthest along versus the people that are talking to us more. But we probably hear equal amounts. But yeah, I think that's certainly something that so it's just again, it's still fairly early. So again, as I said, last April was when it first became kind of an integrated project, and then Postgres just showed up as part of Juno. But a lot of the additional capabilities with Juno, Postgres was really just kind of baseline support, provisioning, resize, with Kilo, a lot of the additional features for backup and replication things are coming online now. Yep.
So one of those config files, when I set up my SQL, was the first thing that I do, go and change the buffer pool.
Yep.
I change the buffer pool based on the available RAM.
Mm-hmm.
So what does the config file look like? Do you be able to do something like that, or is it fixed, or
Yeah, so that's a good question. I'm not sure the answer to that one in terms of whether you can specify the value of the buffer pool based on a percentage of RAM or based on some calculation. I don't think there's a calculation. Yeah.
I try to be a little more intelligent than that.
Yeah.
Wondering what the template is.
Yeah. I don't know the actual answer to that one, so I apologize. But yeah, I think it's something like yeah. Other questions? Yep.
Yeah, getting back to alternative database support, are there plans to support Cumulo?
Cumulo has not come up yet, so I haven't seen anyone doing Cumulo yet.
Which one hasn't?
Beyond what's supported? You just walked in. So the things that are supported, so we'll go through the list. The things that are supported today are Postgres, MySQL, MongoDB, Redis, Cassandra, Couchbase. I'm missing anything. Percona, MariaDB, as well as kind of MySQL variants. I think that's the list. I'm sorry? It's not. It's not. Yeah. Cool. Cool. The ones that are actually there's a number of them that are actually being worked on now. Oracle, DB2, Vertica, in terms of the not open source community friendly, and CouchDB is actually also IBM's working on CouchDB as well. I think I got the list. Yeah. Other questions? Nope. Great. Well, thanks a lot.